Not sure if people are going to be, hopefully you can hear me. Not sure if people are going to be showing up, so I'm going to do a quick post and pause the video for a second and then start up because it's time to start. All right. So I'm going to hopefully share my screen, not give away too much of the answers, although, and then we'll go from there. So let me see if I can, I want to do, yes, I am mumbling, in case anyone's wondering. All right. If you guys can't hear me or no people cannot hear me well, please let me know. And hopefully you should be able to see my screen right now. Yeah, okay. So I want to know what everyone wants to go over, both of you. What kind of topics are you stuck with? What's not making sense in the course? What are you stuck on the assignment parts? Is there something about character arrays you don't understand? Is there something about pointers you don't understand? We can go over all those things. I did this earlier with some one-on-one help with another student. And so I'm just going to reuse a lot of that chunk of code, and then we can go from there. So if you have any, let's see what kind of questions you have right now, and then we can go from there. So what would you like to make sure we go over? There's a char shift. It's not fully done, of course, especially not now. Maybe get rid of it altogether. We'll go over that. We'll live code that thing up in a second. Is there something that I can help you with for the assignment or for course content? That's the point of these things. So,
Yeah, I actually just have a very simple
oh,
question. So in the
I have my
coming
headphones on.
assignment,
Sorry, hold on a second.
okay.
Right now.
So in the coming assignment 11, we are asked to submit a PDF file and a zip file. So the zip file should only contain the PDF file and another CPP file, right?
So let me double check what my instructions, because I realized last week when I was rereading everything over again that it was a little confusing. So I should have made it into submit one zip file. The zip file has all the code you did, and it has a PDF because there's two different parts.
So the code is referring to the refactored assignment 9
Yep,
as in CPP file.
it's not just one CPP file. That's the whole point of refactoring.
Okay. Yeah,
It'll
I was
be
just like, I want to
three.
double check with it because the entire instruction is kind of confusing to me.
Okay, so what's confusing? So I can fix it so that other people don't get confused.
Yeah, I'm just like, I'm not sure if the code folder means the CPP file or there should be something else contained in this folder.
Let's see what these folders look like. That sounds like a plan. Okay, where are we at? Assignment 11. Did that do it? That's the wrong one. Hold on a second. I'm just gonna pull something over. Assignments. Go to review. Let me see. I should have assignment 9. Grades. No, I should have the assignment 9 solution file in here somewhere. But let's just throw in that. Do probably. Here would be just a folder with but would have code in it. Here's my solution file. Now, your code might be in this directory or it might be in a subdirectory. It's this sort of thing. It would be, you would need to include your CPP file. If you had another CPP file, you'd include that. And if you had a header file, you'd include that. If you included everything in this entire folder, meh, perfectly fine. The issue is what I don't want you to do, and it's purely for you, is if you just zip up the entire project, it's huge. These are massive. Why? Because there's this, let me hopefully find it. This thing right here, it's a hidden file that you don't even see unless you show your hidden files. And you go into it, and how big is this thing here? Oh, this is only 483 megabytes for a hidden file when all we want, just to be very clear about this, hopefully, uh, here is the solution file, and it's 21 kilobytes. It goes from 21,000 bytes approximately to 489 million bytes approximately for no reason. It doesn't help at all. It doesn't, you know, It's not part of the project. We don't actually run that code. We aren't going to look at it. It's just extra hidden cruft. These things are massive for no reason because Visual Studio is trying to speed up your ability to program. That's what those auto completions and stuff like that do. It's generating that code to allow you to do auto completions, which means that these projects are big when they don't really need to be. That's why we're only asking for the .cpp file and the .h files. If you find all of them, throw them in a folder, or just the folder where your CPP file is. That's what we want, because that's relatively small. Even all of this together, it's what, 40, let's say 50 at most. Let's just guesstimate it to about 50 kilobytes for everything single thing in this folder. That's not bad, right? Uh, and that would include your header files and your CPP files. Does that answer your question okay?
Yep, got it. Thanks.
Great. And then we're just saying throw in the PDF while you're at it because, well, that way you only have to submit one file at the end. Let me make sure I'm recording here. Still recording. All right, great. So I'm hoping that might be, I want to make sure it's not confusing further. So if there's something in particular that I said that seemed to make it confusing, please let me know. Probably type it so it's easier to include. All right. So what other things are people struggling with for assignment 10? Are you struggling with other stuff? Are you struggling with pointers, for example? I know, let me think here. I had some great questions like, what's the difference between, let me see here. Difference between char, oh, sometimes you see constant char star, sometimes you see char star. What the, yeah, and that's nitpicking, piddly diddly, pain in the bum differences that I didn't have to worry about way back in the day. And I do believe the exam is the 16th. At least that's what I'm aiming for. And I'm hoping that I'm not wrong because I need to make the exam ASAP. I'm in the midst of it, but it's still lots and lots of editing and that sort of thing. By the way, I think there was let me correct me if I'm wrong. There was a version, last term's exam was visible to you guys. All the exam questions, by the way, even if the exam question looks the same, it's not the same. I've changed every single one of the multiple choices so that they're dealing with different numbers. And there are some traps. So in case anyone says, hey, I got the answer from last year's exam, they don't, you might want to warn them. It will not be the same answers. If you understood the concept, you got the same answers, but I'm changing the numbers, so it's going to be a little off. That's all. The website is from fall 2020. Now, do you mean See Learn or our website? The website, I fully stated right up front, this is fall 2020. It's old. It's not the exact dates that we're looking for because it's just for in case you need access to the course content some other time. I should probably put the videos on there too. Shouldn't be a text file. I think I allow a text file, but I don't think there is a text file. It's a good question. So you should be able to pass in a CPP file or a text file. That's all a CPP file is. It does not actually, this fancy pants green and all this other fancy coding, that's not there at all. The actual file itself is just a big old text file. That's all it is. And that's why I'm allowing a text file to be submitted, just in case, you have a compiler and you say, screw it, I'm just going to pass in what I have. Well, it'll work. Pass in a CPP file. All right. So is this character shifting, Caesar shifting thing making sense? I was talking to a student today. It was a perfectly fine questions, but the issue was he or she did not, let's use they did not, read through all the various parts of the question, which is perfectly normal. It's common human error. I do it myself. Let's keep in mind, these are not terms and conditions in an Apple contract. This is not something that everyone just goes, yeah. Or it's not supposed to be something that you do. They're supposed to hint to help you out. Maybe I'm incorrect in assuming that it's going to help you out. It's my attempt at helping you out, at least. It also serves one other purpose, and I'll just be very blunt about it. This is an online course. It is ridiculously easy to find a Caesar shift algorithm or function online. It's ridiculously easy to find the Chinese zodiac assignment online. They're all different. They're all different than what we are doing. We're doing a simplified version of it. The Chinese zodiac thing is nasty, the real one, because you have to figure out the lunar calendar. We just said it's always February 12th. Boom, right there. The character shift thing means that you can't just steal code from online, because if you have to use this function called char shift 1400, now you have to figure out what they're doing, what we're asking you to do, and where the differences between the two are. So you can look, if you looked at a solution online and it happens to match what your actual solution is, great, you just sort of double check your work. But you can't just verbatim just copy and paste something from online. It's not only going to be considered cheating, but it's going to be obvious that it's going to be cheating. In order to get just, to get this function here, you need to understand, you can't find that online, so you need to understand what's going on. This, by the way, the function that we were going to talk about, let's keep in mind a couple things. So I'm more than happy to go over this part of this. The character shift, the Caesar shift cipher. I actually made, what I was doing earlier with this other student was my plan of attack. I read the question a bunch of times. I make sure I understand the question. I don't just, I don't want to dive into coding. I also don't want to just stare at the question and not know where to go. So you got to do some other points in there. So if I'm asking you to write an English essay or write an essay of any format, you don't just stare at the question all day and like, or stare at a blank page. You go, right. You also don't just start writing your English essay. What do? You do some kind of outline, some kind of scaffolding. This is where how I'm going to, the top points I'm going to bring up. I'm going to give some kind of outline for this thing. I may also want to think about through the problem first. So my first step is I'm going to think through this problem. I'm going to understand what they're asking and think through the problem and figure out what's going on. So I'd write char shift 1400, just write down the words char shift 1400. It's going to take in some character like A, like C, like exclamation point, like the character 0 if I wanted to. That's all fine. They're all characters. It has to be able to support any character. It's also going to take in any integer number. And it's going to spit out a character in the end. So the analogy I've been going with is, think of this as a tool. It's a tool in your toolbox. Once I have that tool, I can use it. What I want is a general tool. If I make a hammer, I don't want to know how the person's going to use the hammer. I'm making a hammer. I'm going to use the hammer, but I don't want to think about one and the other at the same time. I just want to say, okay, if I had a hammer, what would I do? I do this, then I do this, then I do this. Okay, now let's make a hammer allowing me to do that. Let's, if I want to, let me say I want to cut my hedges. I need a tool for cutting my hedges. I need to know what kind of hedges I have, because they might be too tall. I might need something to extend. I might need some kind of ladder. I might need some kind of extension thing to make sure I have a nice flat cut. Once I have that, I got to go find, at least I'm not going to make a tool, but find a tool, make some setup so that I can stand up higher on the hedge and cut the hedge. I want a general solution for the task that I'm doing, but I'm going to do it in little modules. I'm going to figure out what the problem is, make a little fix. Find the problem, make a little fix. Little tools, little things to help me along. But I don't want to be sort of conflating the two ideas. So I have a function called char shift 1400. I want to know how that thing works. Not knowing what it's doing, I just want to know how it works. Things go in, stuff comes out. Here is what we worked on. Things go in. If I pass in A, the character A, and the number 2, I shift over 2 positions, I spit out a C. That's what I would expect. If I pass in Z shift it over 2 positions. It loops around, goes A, then B, pops out of B, 2 positions over. It loops every single time. If I do Zn minus 2, it should technically, this is the bonus part of the question, it should go back to X. If I pass in the character 0, it doesn't do anything. If you give me anything than a capital character, it just goes and ignores it. So if I give it exclamation point and 20,000, it still gives me exclamation point. Doesn't matter what the heck you throw at this thing, it's just going to do what you're expecting it to do. If I give, let me see if I can, you already saw the answer, but if I say AN 29, what would I expect? You can put it in the chat, you can say it out loud, whatever you want to do. So 26 characters in the English alphabet. We're relying on the English alphabet in this case. Caesar shift presumably would be the Latin alphabet, properly Latin alphabet, but we're going to ignore that fact. What would I expect to see if I shifted it over 29? That's more than the number of characters I have, but remember, this thing loops around. I'll wait, by the way.
Would it start going into like lowercase again?
We're going to stay only uppercase. So when I had Z and I added 2, that's a great question. If I started Z and added 2, I looped around back to A and then B. So 2 more, I cycle around.
Yes.
So what would 29 do then? Or 26?
Like it would start the loop back around.
It's going to start going back around. Great. So what position are we if we go back around? If I add 26 to this, what do I get?
Is that just back to A?
That's
Or
right back to A.
B, I guess. I don't know.
So
Yeah.
I said 29. So what's that going to be then? "26 gives me A, 27 gives me B, 29 gives me what?
C.
27 gives me
Or
B.
C.
Sorry? So
No,
if 27 gives
sorry,
me,
my internet's cutting out.
okay. If 27 gives me B, 28 gives me C, 29 gives me D. I have to do it
D,
out
yeah.
loud. I can't do it in my head. I'm bad at that sort of thing. So it's going to give me a D. Great. We're going to test this. Why? Because we want to know if the thing works. I was even a smart ass here because I did this 20,000. I was curious. I don't know what the heck it's going to give me. 20,000, but it has to be any integer passed into this thing. For us, we're saying, okay, don't do it if it's a negative value. That's for the bonus points. But I should be, according to this thing, it can take in any integer, take in any character, and it should handle it properly. So I wanted to find out what the heck would happen if I pass in A and 20,000. That means it's going to go through the alphabet.
Like the alphabet a million times.
20,000 divided by 26 times, to be exact, and then whatever is left over.
Mm-hmm.
Right. So I could do this a whole bunch of different ways, by the way. So I just want to play with some numbers and make sure I know what I'm getting into first. I don't want to just start like coding. That is a kiss of death. Know what the thing is going to do, or have a hypothesis what this thing is going to do before you jump into your code. Okay, this is what I would think. I don't know what this is going to do, so that's not a great test for me. I don't know what it's going to give me. I could break out the calculator though and say 20,000 divided by 26, and then see what the remainder is. That would do it for me. Okay. But the other ones, they're perfectly fine tests, right? I want to think it through. Okay, next step. Once I do this, I want to code this. So first things first, I need to know if something is between A and Z. There you have it. This is not, I'm ignoring the lowercase a and z. I could include the lowercase a and z. That would be fine. In that case, I would do the following. Else if, being lazy again. And why am I using the a's and z's here, not the numbers? Because I don't want to know what the hell the numbers are. Therein lies madness. I don't want to remember that uppercase A is 67 in ASCII. I happen to know that, but I shouldn't have to know that. Save yourself some brain, save your brain matter. Just, is it greater? This is a character, but it acts as a number. So C in ASCII is what is 2 greater than what at 67, 69 is uppercase C. D is 70 in ASCII. So let's say my character here is D. Well, I'm checking to see if it's between 67 or whatever the heck Z is in the ASCII numbers. That tells me if it's in that range. Okay. And the easiest thing I could do here, and it's not going to be the right answer. There's 2 different approaches I could do here, but let's do this. Shift char is equal to shift char plus, if I can type, shift num. What will that do? It's not going to be necessarily the right answer, but it's going to be the right answer a lot of the time. So I'm going to do a little bit at a time. So if this was 2 and this is C, what do I get? C, D, E. That's what shift char is now. If I return shift char, we're all good to go. I'm going to do the same thing down here, by the way. But now the question is, what happens if I go beyond Z? Let's say I add 20,000. And this is up to you. You could do it 1,001 different ways. I got cutesy with the math using remainder, but you can do it a different way. So what I did is it's this number. I shift it down between 0 and 26, do the remainder, and then shift it back over again afterwards. So in case you're wondering what that would look like, it would look something like, what would that be? That is, this should be, if I have shift character plus shift num minus a, ideally what we'd expect it to be somewhere between 0 and 2 and 25, right? I'm removing what, so I can play with some numbers here. Let's say it's C is 69. So and let's say shift number is 2. This would be shift num plus 2 is going to be E minus A, the value A. So E is A0, B is 1, C is 2, D is 3, E is 4. It's the value 4. And then if I did it back to the character E. So why the hell would I do that? This does nothing. This is, I added this amount and I take away that amount. It doesn't change anything in my calculation. Except what if that's a number between, that should be a number between 0 and 25, right? So what if I did that? Now what happens? E goes to 4, it goes back to E. If I have some value like 27, it becomes some value between 0 and 25, and then shifts it back over again. It allows me to not use a loop. Or while shift char is greater than Z, shift char minus equals 26. That would also do it, right? Just keep on moving it down until you get to character again. Get rid of all the loops that we have. So if it was 20,000, we're going to do a whole bunch of loops. This one, we don't have to do any loops. They're doing the same thing. But this is just, this part right here is the hard part, but it's not worth that many points. If you happen to get almost there, but you miss X, Y, and Z, pass it in. That's fine. It's a little bit off, but it's not the end of the world. The extra little polish you put in there to make sure it loops back around, that's what this thing here is. So just taking the shift number plus the character, adding the shift number, returning that, that's going to get you, 80%, 90% of the marks. And then this other stuff is just playing around with the numbers to make it work, whatever way you want. You can use an if statement. I used a loop because the number could be really huge. The shift number could be really huge. It doesn't make sense to make it really huge. So an if statement would probably be more than acceptable. But if you put a really huge number in there, then you need to handle that. What if I put a negative value in here for the shift number? Can you handle that? You don't have to handle it for this assignment, but you can handle it for this assignment. That's your prerogative. That's the bonus, whether you can do the encoding and the decoding. All right. Is that making some sense? I hope. Everyone goes quiet when they get confused, or they're thinking they don't understand something and everyone else does. I promise you, if you don't understand something, other people don't understand it too. So that's fine. It's not fine to just let it slip by. I like to fix things for you guys. So is there anything I can unpack, sort of clarify in this? I'm just going through my thought process. How do I break down this big, nasty problem into little steps and build out from there? And I want to make sure when I'm doing it, I play through a bunch of examples first. So if this tool of mine works, what should happen is these should all be true. That's it. Okay, let's see what I can do for Hail Caesar shift cipher. Okay. Oh, it's not even being called. That's fine. So let's see if I can. We're going to get this thing to compile. Okay. Oh, that's going to give me an error too. The reason it's going to give me an error is my code is officially saying it's not handling lowercase. If you look at my assertion down here, there's a Z, lowercase z. I subtract 2. It's saying it's going to give me z again, which is not true. You can use malloc if you want. That's a great question, Danny. So you can use malloc or calloc. I'll even show you where the malloc is being used. They're the same. They're almost exactly the same thing. More importantly, they're both crappy. Sorry, I love bashing malloc and calloc. It's not because I'm not going to pretend that I think they're the most brilliant things. I think they're old, much like the English language. The English language is an old language. If you were designing a language from scratch, like a verbal language from scratch, it would not look anything like the English language, right? You'd have all these rules. You'd stick to those rules. And you'd have this rule and that rule. And instead, the English language is this weird hybrid of a whole bunch of different, well, Germanic and Romantic languages, just sort of smooshed together with a whole bunch of exceptions to the rules, and just figure it out as you go along. If you were designing it, you wouldn't do it that way. C, it's such an old language that what made sense in the 1980s, memory allocation as the name of the function, makes perfect sense. Doesn't make a lot of sense nowadays, not how people normally think about code. You also wouldn't be doing all this pointer crap if it wasn't for how old C is. Right? That's all normally hidden away from you in most modern languages. It does mean when it's hidden away that you don't know what's going on under the hood. We sort of need to know that. But so malloc, calloc, it's clean memory allocation. I think that's what the C stands for. Malloc is memory allocation. That's it. That's the only difference between the two. The syntax is a little bit different. One uses a comma, the other one uses a multiply. That's it. You're asking for this many bytes of data from the system. That's all you are doing. So here is malloc. I'm asking for however big a character is, this many characters. I want to actually move this. So let's say not the answer. Okay. Just in case people were going to steal that. Malloc just says, give me 200 times 1. That's how big a character is. So 200 bytes of data. I always throw in that size of, even if it's character, because you don't know what's going to happen. You don't, integers have changed in my lifetime. The size of an integer has changed in my lifetime. Size of lets you handle that, and your code doesn't break. If they suddenly tomorrow say, no, a character should be 2 bytes, you can handle it. You cannot handle it if you don't have this thing. So you're saying, I want 200 bytes of data. It says, here's a big chunk of 200 bytes of data. Here you go. Do with it what you will. It's your job to give it back at the end of the night. So let me get to, let me just run the code first, just make sure that's run. Hey, actually compiles. That's surprising. Okay. I'm actually serious. I don't expect the code to always compile. That's fine. That's why we do it methodically a little bit at a time, even after all these years. All right. And by the way, shifting A 20,000 places gives you the letter G, by the way, in case you're wondering, if anyone was really concerned. A, B, C, D, E, F, G, 6. There's 6, remainder 6. 20,000 divided by 26 gives you remainder 6. Okay. So that's what is, if I was doing it for A. But notice all my assertions, they all passed. Nothing blew up in my face. Earlier today, I accidentally wrote, I think, 27 and said it was A. I just had a little typo in there. It blew up in my face. I had an assertion error. I was able to track it down really quick because it said, hey, it's broken right there. So this is all the different tests I was going to do. Hey, it passed all the tests when I run my code here. Great. We're good to go. How about this one? So Hail Caesar shift, by the way, the difference between Hail Caesar shift and Hate Caesar shift is just how we're accessing the individual elements in the array. That's it. The reason is because of this. So here's me making an array. Fine. Normally, I'd say I'd go into bucket 3, let's say. So here is bucket 3. I go into the 3rd position in my array and look at what the value is. The array is just, all I have for an array is I get a chunk of memory and I have a pointer to the front of the chunk. This stuff is yours. This big chunk of memory is yours. Here is the pointer to the front of it. Fill it in, do with what you want. You rent a storage unit, do with it what you want. Put whatever you want in there. I was watching, that's San Marino Diet. What is it? Santa Clarita Diet? Santa Clarita? The zombie show, right? They have a storage unit. You have body parts in there, right? You can do whatever you want in the storage unit, unfortunately, right? There were bad guys that they were eating, so it's fine. Anyways, you have a storage unit. You can put stuff whatever you want in there. It's your storage unit. They just say, this is it. It's over there, and they give you a key. They point you to where your storage unit is. You do with what you want with that storage unit. So I get a storage unit. I get a chunk of memory. I get the key to the storage unit. That's where it's located. It's at position 32 or whatever the case is. I walk over to the storage unit and I can open it up. I can deal with it. I can use it. But I know where it's located. That's all I get. So for this, if I know where this storage unit is, I say, okay, well, it's actually not one storage unit. It's a whole bunch of little things in a row. Like, think of it like a grid of boxes or a whole bunch of boxes in a row. They're all yours though. So I'm going to go to position 3 and get the value. That's what that thing here says. That's equivalent. Oh, I have another example here. Here we go. Here we go. That's the better example. This is the exact same as saying, go to the start of my storage unit or start of my storage, move 3 positions over. So move my pointer where I'm pointing to 3 positions over, and then look in the box. That's what this thing here says. I'm at a pointer, look into the value where the pointer is pointing. To the point that this is equal to that. That if I have a pointer and I dereference it, I get the value inside. And then if I say, give me the pointer to what that value is, I get the original pointer again, which is also, by the way, equivalent to pointer a nums. They are the asterisk and the star do the opposite thing. One references it, one dereferences it. So I get the pointer to this pointer. It's got to be stored somewhere, right? I'm storing an address, like writing in a book where the person's address is. I'm pointing, I'm saying, oh, by the way, the book where that address is, it's over there. It's a pointer to a pointer. So knowing where your phone is and your phone having the address in it, which then allows you to find your friend's house, right? So the pointer to a pointer to the actual thing. And then I say, okay, what is in the box? So the pointer to this thing, what's in that pointer, where, what's in that box. And that's the exact same as saying this pointer. It gets really weird, but that's why you have to play with it. Honest to God, you can't memorize it. Just make a whole crap ton of these. So here is one example. This is the kind of exam question I unfortunately do. I'm a meanie, right? Here is a pointer. Here is a pointer to the array. I'm going to the third position, 0, 1, 2, 3, and the fourth one, but we start at 0. But I'm going to position 3 and getting the value, which is exactly the same as saying, go into position 2, get the pointer to position 2, and then once you get the pointer position 2, then go one step over to the right, like one more position over and look in that box. That's position 3. So I can do all sorts of crazy pants things. And if I have a list of these sorts of things, a list of pointers this way, and I have a matching problem, that can show up on the exam. It has shown up on the exam before. It makes it easy to ask these kinds of questions. So if I add 3 and then take away 2, what's that equivalent to? Okay. Just if this requires practice. Okay, so this is asking for a chunk of memory. I get a pointer, the location where that chunk of memory is. I'm then going to go to each position in the chunk of memory, which is going to be a character, and then I'm going to convert it. So, sorry, I go through each position in this chunk of memory, get the character, and then store the decrypted text when I get a decrypted character, and I stuff it in this new array. I'm hoping that makes sense. Let's do the malloc version of this, by the way. So instead of this, it's malloc, and it's the size of and comma done. Now the question is, why would I use malloc instead of malloc? Malloc cleans it up. That's the only difference. Malloc will give you whatever the hell was there, for good or bad. If you plan on cleaning it out anyways or setting it to a whole bunch of safe values, malloc your friend, right? Because you're going to clean it out anyways. If you're not sure you're going to clean it out or you want the default zeros for everything, use calloc, great. But if you have to set all the values, let's say you set all the characters instead of to zeros, you set all the characters to A. Then use malloc and then set all the characters to A afterwards. They're the same thing. You can use either one of those. Okay. Is there questions about hate Caesar versus hail Caesar? Hate Caesar is instead of using this sort of thing right here, or instead of using this thing here, I'd use something like this. Just to get you the practice for how those things are equivalent to each other. Not magic, it's not, this is a convenience. This is, see that where I'm pointing over there? Go 3 positions over and then look in the bucket. That's all that means, which is the same as, see that where I'm pointing? Go 3 positions over, look in the bucket. All right. I would like to point out something else because I brought this up earlier. I don't know if this is going to help as a metaphor, but I like it as a metaphor. I don't know. So I got a couple things I want to make sure we go over. With memory, it is very, very similar. What we're doing with this thing here, hail Caesar shift, is very similar to you moving into res. Now, you guys didn't move into res this year, but you would be moving into res presumably 2 years. I have no idea. Maybe never, because pandemic just sucks. If I'm moving into a res, or if I'm trying to rent an apartment, or whatever the case is, what do? I ask for my key. First thing, I apply to the place, I get a key. I cannot move in until I get that key. When I am done, they give me a key. So I'm asking for the key. That's the equivalent of malloc, right? I'm not moving into that apartment until I apply for the apartment and they give me a key. I have the key in hand, I can pass that around or I can use it. So if I get the apartment, I get a key. That key can be passed out, it can be passed into other functions. If I want to set up my apartment, if I want to move into my apartment, I take my key, pass it in as input, and then I can do stuff with it. So here is Hail Caesar. I'm getting my key. I am then using my key. I can then return the key, and then I can use it. I can use that character array, just pass that character array into a printf statement to print off what the new message is. The point of the matter is I can make an array in a function, pass that array out of the function, and then I can just keep on using that array until I'm done. When I'm finished with my apartment, what do? I got to give back my keys. That's where I free my memory. And it's not done in Hail Caesar shift. It's done whenever I'm done with the memory, when I'm done with my apartment. So this is apply to the apartment, do some stuff, live in my apartment essentially. And then when I'm finally done, then I can give back my key. They're not doing it at the same time. Everyone took off on me here. So I'm wondering what is so boring about what I'm talking about, given the fact that it's on the assignment. I don't understand why people wouldn't necessarily want to listen, but okay, unless it's obvious and they understand it. So let's find out. Okay, Andrew or Danny, can I unpack anything else? Because it's very disconcerting is not the word I'm looking for. Demotivating. When it comes to everyone, like it's so hard, and then they just take off when you're doing a synchronous lecture. So can I unpack anything for you guys? Nothing. Okay. What's the difference between, oh, let's see it. All right, I'll hit Andrews first. What's the difference between P, this P, and star P? P, well, we don't know what a pointer, so is P a pointer? That's the first question. Oh, the name of the pointer is P, great. So P is a pointer. What does this ampersand P mean? It's a pointer to a pointer. if it's like a scavenger hunt, right? If I say the clue is over there, I get but I can get a clue to a clue and a clue to a clue to a clue to a clue to however back I want to go. This is saying the pointer has to be stored somewhere. A pointer to the pointer just points to where this pointer is being stored. There's a lecture on this, by the way, in case you want to see a better example of it. There's a lot of lectures, so understandable. So the star asterisk pointer P is go to the location, look at what the value in that location is. So the asterisk P says dereference it. I have a pointer to this thing. So let you have my address to my house. You go to my house and look in my house. The ampersand P is you have an address to my house. Your friend now has an address to your house. So they go to your house to get the address to my house to find, that's essentially it. Okay. Does that unpack things, Andrew? It gets really crazy pants because you can also do math with this stuff as well. They're just locations in space. That's all a pointer is, but it allows you to do some really crazy things. Okay. Yeah, pointer to a pointer.
Maybe could you go over the one where it's like you have to enlarge the dynamic array?
Oh, sure. So how would let's see, what I had here. I had a struct. Do you remember what the struct was named? Super array or something? Let's call it super array. I don't know what I called it. Okay. What did it have it inside? It has an integer.
Yeah, super array.
Was it actually called super array?
Yeah.
Oh my God, I'm not original in the least. Okay. Oh, good. And we have the size of the array. We need to keep that size around. Unlike a character array where we have that magic 0 at the end to say, hey, we're done. There's nothing I can put into a character, an integer array that tells me what the end of the array is. I just have the start of where this array is. I've got no clue how big this thing is. There's no magic character at the end to say, hey, I'm done with my array. So I need to keep that around. So int array size, I think was the name of it. All right. So if I pass in one of these things, I have everything I need to do. Presumably, if I have an array here, I have everything I need for this array. So let's do maybe a setup array. So super array. Let's make the function called setup super array. And maybe I have in starting size. Okay, I'm going to make a super array. I'm going to set up everything with malloc and everything like that. Return my super array when I'm done. And the whole reason I'm returning my super array when I'm done is I need to be able to use that afterwards. So super array, that's the name of my structure, my struct SA. Yeah, it was super array because I kept on calling it SA, didn't I? All right, this is going to make a structure that has a pointer, just a pointer. It's not an actual array yet. And the size of the array it's going to be. Nothing is set up, by the way, by default. SA dot array size is equal to starting size. SA dot, and then I have my array, my numbers. And then I need to call this malloc thing, right? So I'm going to call int. So I need to make a new array. This is just an address, just somewhere in memory. So I'm going to get memory. I'm going to set the address and set where it's located and stored in this thing. So I always use size of, and then starting size. All right, so we have a couple things I'm going to play with here. If I want to be really paranoid, here, let me be paranoid. So assert starting size is greater than 0. If you tell me to make an array of size, or maybe it's got to be at least 5 or something like that. If you tell me the array size is -1, it shouldn't work for me, right? That's a bad array size. So I can make sure that it's, let's say, greater than 0. So this is going to make a starting array of that size, of the size of an integer multiplied by whatever this number is. Let's say it's 20. 20 times 4 bytes for an integer, 20 times 4, 80 bytes of data. I'm going to say, no, it's not 80 bytes of data. It's 20 integers. And you go, okay, it's 20 integers. That's all it is. That's what it's saying. It's a pointer, an integer pointer to the front of this bunch of integers. Okay. I want to also check to see if this worked properly, because this could be null. If it's null, it means things went boom. It didn't work. Back in the bad old days when we had limited amounts of memory, we still do have limits to our memory. But let's say I asked for 2 megabytes of array. You may not have had 2 megabytes around. Maybe you're asking for 4 gigs now. The computer is going to go, no, I'm not giving you 4 gigs. Go away. You can ask for ridiculously large arrays if you wanted to. In fact, if I put a negative value, like a -1 for starting size, this thing is going to be massive. In terms, the array that you're asking for is massive, and bad things will happen, right? So I don't want to go through that. So heck, I can even just make sure my starting size is a reasonable amount as well. But I want to check to see if this worked. So if sa.a nums, so here's where I'm going to go flip things around a little bit. If that's equal to null, as in it did not work, bad thing, didn't work. This is me being overly paranoid, by the way. You wouldn't have to do this for the assignment, but if it doesn't work, I want to say sa dot array size is equal to 0 or some safe values, right? Bad crap happened. I don't have an array at all. Okay, just leave this alone, right? In all cases, though, I'm just going to return SA. Your actual assignment is going to do something very, 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 very similar to that. What's the difference going to be? Well, let's say I have an input starting array. I want to double the size of that. Do I have the original size? Yeah, it's in here. So let's do, I'll do it as a sort of a, I don't want to give the answer necessarily, but I'm going to do it as a sort of suggestion. I say, okay, how big is the original? It's original SA dot array size. If the new array is twice that size, well, what if I had this and that? So I'm going to put a comment in there, not give away answers. What if I just multiply it by 2? Okay, it's bigger. What if I call malloc? Great. Now I need to transfer all the old numbers over to the new ones. How many old numbers do I have? Well, I have this many old numbers, don't I? Sounds like a for loop to me. Copy everything over. So I make a big old array, copy everything over. And this is, maybe I have a maximum size or something, whatever the case is. Or maybe I want to copy everything over and then set all of my new elements. Yeah, I have a maximum size, I think, in this one. It's array size and max size. Something like that. So array size, sa.max size. There you go. Using starting size, okay. Max size, okay. In this one, I have, we're going to double the size of my max size. The array size is going to be the same no matter what. The number of elements I'm using, how much I'm using of this. Let's say I ask for 20 array of size 20. I'm only using 10. So array size is 10, max size is 20. I'm only using 10 out of the 20. And I have this array of size 20, but I'm only using the first 10. Does that unpack things? It's going to look very, 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 very similar to this thing here. But the only difference is now copy the old values or to that new array, turn SA. That's it. I copied everything to this new array. Oh, I also need to copy everything over the new array. Oh, then free the old array in original. I'm never using that again. So let's free up that array. So that would be something like original SA dot, and then I call free on it. And then just because I'm anal retentive here, you wouldn't need to here, but I'm doing it anyways because I like being in that habit. Set it to null. And then maybe what I want to do is array size is equal to 0. Just setting it to safe values, just in case something weird happens. Nothing weird is going to happen, but just to be absolutely 100% positive the things don't go horribly wrong. So let's say I pass in this array, original array. Somebody else, no, that doesn't work either. I can't think of a good example where it's not gonna, where this is where I would need to do these last little steps, but I just, out of paranoia, I always do it. Set it to safe values when you're done. Just get in the habit, set it to safe values when you're done.
So for the function has the perimeter of the starting size. Do you define the starting size somewhere, or is it kind of just created?
I think for me, I did a default starting size. You can make a default starting size for any of what like your super array. Just have some default, like some constant, like constant and default as a size, something like that, and use that to begin with. But I do need to start the ball rolling, right? So my starting size here, it would be, I'd call this function set super array and with the value this. So let's do that actually. What do I call this function again? Set super array. There we go. So SA is equal to set up super array. I'm going to have whatever my default starting size was. 20, let's say. Okay. And then what else can I do with this thing? Nothing really. There's what I could do is this sort of thing. And I 0 less than s dot array size. And you're probably wondering, what's this going to do? And you are right to wonder this because it's going to do absolutely nothing. Let's have a look at where, let me see where, I do it up. Let's see. There we go. S8 dot a nums at position I. Array size should be equal to 0. This shouldn't be called at all if I don't do anything with it, no matter what. So that would be fine. If nothing is actually going to, nothing should be printed off here at all. And then I could do like something like print f super array size. If I wanted to make sure I have something output. And this first element is SA dot array size, max size. All right. What is this going to, this is just going to print off what's in my super array. Notice it's going to print off all the contents of my super array if it's not empty, but oh wait, it is empty. Okay, this is, let's comment this whole thing out. Let's set up super array, return SA. Oh no, this is the other version of it. Set up. Call it resize super array. Or let's do this just to use new content from the course. If false, so not true, include this, otherwise leave it out. This is what our pre-compilation instructions are. This allows you to block off code easily as well. It's another way to block off code. Oh, look, what do I have here? Super array is size 0 with max size 20. Hey, it worked. We have an array of size 20. Notice I did something wrong here. What did I do wrong? Can you guess what I did wrong? Well, let's go to my thing here. So here's me making set up super array. Here's me doing this printf. What did I do wrong here? I want to get people in the habit of being paranoid about things. What did I leave off? I left something off.
Did you not free up values again?
Yeah, I didn't free it up before I was done with my program. When I'm done with that super array, I want to clear this thing out. I have a dynamic array in here. I got to make sure that thing is clean. So let's do this. If SA dot not equal, no, SA dot A, I want to free it. Done. The reason I want to do this is what happens if I do, let's see here. Let's do it here. SA dot A nums at position 0 is equal to -2. Just gonna throw in a couple numbers in here. 4. That's how big this thing is now, right? So I'm going to output some things from my array as I was planning to, and then I'm going to do the same, just copying the exact same code over here. Let's see what happens. I have no idea what's going to happen, by the way. All right. I got an error here. That's what happened. So I did all those array things. Array element at position 0 is equal to -2. That's what I set up right here. Array at position 1 is equal to 4. That's what I set up right here. Those are the two values. I had this for loop, which I was outputting the individual elements. Then I'd say the super array of max size of size 2 with a max of size 20. That's what that next line below here is, right here. Then I freed my array, set it to null, and then I did a for loop again, trying to access elements in the array that I have already freed up. A nums, though, is null. This is an access violation, but it's a null pointer exception, really. This thing is null, and I'm trying to go into a position in null, which doesn't exist. I don't have memory there. and output some values. In fact, let's do one thing different than this. Let's see if I can break it another way or not break it and be really scared. Let's find out if it's going to keep on giving us a problem. Because I set it to null afterwards, because this is null, I tried to access the elements of the array and it blew up in my face, which is what I actually want. If it's not mine anymore, I shouldn't be using it. I should be slapping the person in the face for trying to use this thing. It's not theirs. Stop doing that, right? That's essentially the idea. It's giving me a warning that it's uninitialized. Great, but that's not really the same as, there you go, no errors. Just a really crazy number. It's not my memory. I've given it back to the system. Some other program could be using that chunk of memory. I'm completely unaware of if anyone's using that memory anymore. And now I am getting access and outputting stuff from that memory. And if you don't think this happens, I can say it used to happen almost on a weekly basis when I was a programmer in industry. This stuff happens all the time. It's why we want you to be paranoid. That's why I want you to put nulls in there. Because if you don't put the null in there, I still had access to something that I gave back to the system. That's really bad. That's why we do it this way. Okay. In fact, I could even potentially change the value for this array here. And I'm not sure if it's going to work or not. Let's find out. But I might be able to actually change the value 3 and not have it blow up in my face. And that's really bad. Yep. Didn't blow up in my face. Oh, wrong one. Didn't blow up in my face. Not only did it not blow up in my face, I stumped on memory that wasn't mine. Blissfully unaware that I gave that back to the system. Some other part of my program asks for an array, gets that same chunk of memory from the system, and one part of the program is stomping on data, unaware that another part of the program is accessing and reading that data. It gives you the craziest, most bonkers errors you can imagine in your program. If you do something like this, if you don't set it to null, if you don't set the safe values, if you don't, in active paranoia, make sure everything is safe, you will get things like this where I'm stomping on memory that's not mine. I've moved out of the apartment. I kept a key. I went back in the apartment and just started cooking toast or I don't know, making soup or something like that in somebody else's apartment. Somebody else's apartment. You got to leave it alone. That's why you have to give your keys back. That's why you have to, when you free your memory, you make sure you do not have a key to that memory anymore. That's your job. Because bad things will happen if you don't. All right. We are running. I don't know how many other questions you guys have, so I want to see if other questions, but I can let you guys. I can let everyone go because there's 2 of you. If you don't have other additional questions, that's what we're actually testing, by the way, at the brand. Yeah, Danny.
I think I'm doing okay. Thank you.
All right, great to hear. I think you guys are being showing up to synchronous lectures because you might be a little confused on some things, but you get the material, which is fantastic to hear, and just keep plugging away at it. It's the people that show up at this are not the ones I'm normally concerned about, but keep up the good work.
Oh, well, I don't know. It's the end of the year-ish.
It is, and it's all confusing and everything is due all at once. And every one of your profs have gone through this and every one of us were like, why did we do this to us? And then we do it again every year, both as professors and when we were students. We wondered why we did it to ourselves and we went right back to it again the next year. So it's, you have our sympathies. It's challenging, I know.
No, yeah, great. So,
All right. Thank you very much, guys. I'll talk to you later.
Awesome. Thank you.
All right. Cheers. Bye.
have a good day.
You too. Bye.